Today we're going to be working on section 3.4, solving equations with variables on both sides. You have the equation 13 plus 5x equals 2x minus 8. Your first goal is to get the variables all together on one side and the constants on the other. I don't care which side you go to, but they have to be on opposite sides of the equal sign when you get done. So I'm going to move the 2x, which means I have to subtract 2x on both sides, over to with the 5x, so that I end up with 13 plus 3x equals negative 8. And then I will move the 13 over to the right, so that's with the negative 8. That means I have to subtract 13 on both sides, and I will get 3x equals a negative 21. Now we're down to that one-step equation where we'll divide by 3 on both sides and have x equal to a negative 7 for our final answer. Let's try another one here. If you want to try this one by yourself, stop the video, do it yourself, and then turn it back on. When I move my variables to one side, I am going to move my negative 3k over to the right. I do this so that I am left with a variable that has a positive coefficient in front of it. So I have my 17 plus k. Then I can subtract 17 on both sides and end up with negative 8 is equal to k. Now, there is another way of doing this problem. If you do 9 minus 3k equals 17 minus 2k, and you add 2k to both sides, you will have 9 minus k equals 17. When you subtract the 9 on both sides, that gives you negative k equals 8. Now there's a negative 1 in front of your k. So you need to make sure and multiply by a negative on both sides or divide by a negative 1 on both sides. Either one works, so that you end up with k equals a negative 8. It's much easier to work with the positive leading coefficient than to work with a negative in front of the variable. Both are possible, though. Let's also work with grouping symbols. When you look at the 1/5 that is here, the 5 that is in the denominator is divisible into both the 5x and the 20 inside the parentheses. So I can distribute that inside to both of them and not have wicked fractions. This actually works very well on this problem. 4x minus 5 equals, then we will have 1x plus 4, because the 1/5 times 5 is 1, and 1/5 times 20 is 4. And now again, we will be getting our variables all to one side, so that we end up with 3x minus 5 equals 4. Add 5 to both sides, and have 3x equals 9. And when we divide by 3 on both sides, then we have our x equal to 3 as our final answer. There's another way of multiplying by the reciprocal on both sides. I caution you on this because you will have to make sure and multiply by 5 over 1 here and 5 over 1 on the left-hand side to everything on the left-hand side, which means then that you have to do a little distributing here and have 20x minus 25 equals 5x plus 20. And you can still get to the same answer by subtracting your 5x on both sides and have 15x minus 25 equals 20. So add your 25 on both sides and have 15x equals 45. And when you divide by 15 on both sides, you get x is still equal to 3. Numbers are larger because you had to do multiplication the distributing of that 5 to the 4x minus 5 in the grand scheme of things. Both ways are correct. When we look at this problem, you see that the 3 is divisible into both 6 and 15. So it would be a great idea to do the distributive property here because we won't create new fractions. So let's have 8y minus 6. When we take the 2/3 times 6, the 3 divides into the 6 2 times. That means we're left with 2 times 2. So we have 4y. Here we're taking the 3 into the 15 and having 5 left over. So 2 times 5 is 10. And now we have an equation with variables on both sides. Again, I would start out with subtracting the 4y on both sides. 4y minus 6 equals 10. Add the 6 on both sides and have 4y is equal to 16. And then we can divide by 4 on both sides and have y equal to a positive 4. Let's do a story problem. The music website sold 94 single songs and 67 albums today. The number of single downloads has been increasing by 22 each day. The number of album downloads has been decreasing by 5 each day. If these trends continue, in how many days will the number of single downloads be 10 times the number of albums? So single downloads be 10 times the number of album downloads. Write an equation to find the number of days. Well, as we look at this, we see that we have the number of single downloads is increasing 22 each day. The album downloads has been decreasing 5 each day. And we want to know when the single downloads will be 10 times the number of album downloads. So let's set up an equation where this word B is equals in the middle. So we want the single to be 10 times what the number of albums are. So we got single equals 10 times the number of album downloads. Well, the single downloads have been increasing 22 each day. So we're going to take the number of singles plus 22 times the number of days. Well, how many singles were there? There were 94 singles, so we're going to put 94 in here. 94 singles plus 22 every day. And then we have 10 times the number of albums. Well, the number of albums is decreasing 5 each day, and we know that there are 67 albums. So 67, and it's decreasing, meaning subtraction, 5 every day, and we want to be 10 times that number of downloads. So we have our equation, which involves some distributive property and variables on both sides. Let's start out with that distributive property and multiply. You're going to have 670 minus 50x. Then let's add 50x to both sides so that we keep our variable positive. So we'll have 72x plus the 94 equal to the 670. And we will subtract 94 on both sides. So we have 72x is equal to, let's see, borrow, that became 6, borrow, that's 16, so 7, 576. So now we're going to take 576 and divide that by 72. And that is going to give us 8 days. Please notice I put a label on that. I expect labels on your equations as well, or your answers to your equations. Thank you. Some equations are true for all values of the variable. These equations are called an identity. And so what we need to know is that when the solution is all real numbers, we can write an R, or we can write the word all real numbers, and some equations have no solution. It's like, how do we know which one is which? Well, let's take a look here. We have an equation 5x minus 6 equals 5 times the quantity, x minus 1. When we start solving this by getting rid of the grouping symbols, we know that we're going to subtract 5x on both sides. That leaves us with negative 6 equals a negative 5. True or false statement? I'm hoping that you are thinking that this is a false statement. And since this is a false statement, that means there is no solution to this problem. You can write the words no solution, that will be your answer. If you want to write no soul, I will accept no soul as an answer. When the variables drop out and you have a false statement, there is no solution. Working through this problem, you see that you can do a little distributive property, 12x plus 6. Whoops, let's make that 12x plus 8 equal to 12x plus 8 on the right-hand side also. If we subtract 12x, our variables drop out and we're left with 8 equals 8. I hope that you are thinking this is a true statement. And since it's a true statement, all real numbers will work for this problem. I can put any number I want in for x and I will always have a true statement because the variables drop out and the numbers that are left are equal to each other. If you want to write just a capital R, I will take a capital R, or I also will take the words all real numbers. You'll see me usually use a capital R. Remember, the variables drop out and you have a true statement when you're done. Just the steps for solving linear equations: use your distributive property in order to remove any grouping symbols. Simplify each side of the equation by adding like terms along the way. I see I have a typo there. Let's make that correct. Collect variables to one side, constants on the other, and solve for the variable and check your solution. Now, in class, we're going to be going through some problems. On page 157, these 5 problems. Feel free to stop the video, work through these yourself. I'm going to put the answers up. If you have questions, please make sure you stop by and see me. Here come the answers. Feel free to come and see me if you have any questions about how to solve or work through these problems. Have a good night.